Hello everyone and welcome to Hashing It Out, where we'll be bringing interoperability to Dash and HLS. I'm Zachary Cava, Video Platform Architect at Hulu, and Chair of the Dash HLS Interoperability Group at the CTA Wave Project. Today I'm co-presenting with Patrick.
Good morning everyone. I'm Patrick Gendron, Innovation Director at Harmonic. I'm also co-chairing the live group at Streaming Video Alliance.
Today we are going to talk about the interoperability of well-formed CMF content between the Dash and HLS manifest formats. To do that, we'll start with a brief overview of CMF, focusing on its goals for a common format and its expectations as it's set in the industry. We'll follow that by the reality of interoperability challenges faced by real-world scenarios today, and close by highlighting the ongoing work in the Dash HLS Interoperability Group at the CTA Wave Project that aims to solve these challenges. Patrick, over to you to start us off.
So let's start with a short overview on CMF, the targets of the standard, the technology selected, and the expectation it created inside the industry. So we know that having several delivery formats is not good for sustainable business, and fragmentation in general is an issue. So to address this issue, big internet players decided to define a new format that would be common for the distribution of media over the internet. The priorities identified at that time was in 2015, if I remember well, was to combine broadly adopted MPEG technology, but reduce their scope by using some profiling. It should support adaptive streaming for live and low latency and on demand. It should enable DRM interoperability, enable efficient and interoperable encoding, caching, and delivery, make presentation, composition, and decoding simple to address as many devices as possible. And it should be designed for having in mind new format, new application like different HDR flavors, virtual reality, and all these new things that that the standard should support. So what were the core technologies selected? Media file is using ISO-based media file format. It uses command encryption that can be either CTR or CBCS schemes. There were some constraints expressed on either video track and audio track, and selecting a small set of audio and video codec, which are the ones that are currently used on the existing services. AVC, HEVC for video, AAC and HEAC for audio. There was some constraints also on subtitle and on caption using WebVTT, IMC1, and 608, 708. With that, CMF packaging could enable convergence between HLS and Dash, having a single set of media files being stored on the delivered across the CDN with simply different playlists and manifest delivered to the different device. Regarding the content protection, CBCS seems to be the real command encryption scheme selected that should be used for any device being HLS or Dash. So different view of this convergence stack, which gives good hope that having command media chunk, command scrambling, we can have really command workflow. So we are very close to that, but we are not yet there. This created many industry expectations. So first one is to make possible a command workflow with command caching of the content, just two different manifests. Encryption was identified at the beginning as a hot topic because it touched some legacy hardware device that cannot be replaced in one day. But nevertheless, that new CMAR standard should improve profitability of the services, as in any case, this simplifies the delivery chain. And the last point, expectation is that CMAF using CMAF chunk is providing a very good format to achieve live delivery with latency on par or even faster than broadcast.
With all these features and functionality, CMAF would appear to have a great unifying interoperability story for the Dash and HLS formats. However, what looks good on paper does not always translate to reality. As early adopters began implementing CMAF, they observed differences in implementations that led to incompatibility of content across all devices. These issues have been great enough to stall the wider adoption of CMAF, as many have asked, why adopt something that cannot practically enable their goals of simplified streaming delivery? As an industry, we recognize that CMAF can help us simplify delivery, but in order for it to do that, the missing points of interoperability between manifest formats must be well defined, and by specifying these, we will drive greater adoption of CMAF faster. To illustrate our point, let's take a look at Dash and HLS interoperability with CMAF in 3 of the most common streaming scenarios today.
The first scenario where CMAF is already a game changer is the low latency live streaming. Low latency streaming finds some natural application for sport events where it's important and it's critical to be on the live edge. Nobody wants to be spoiled by social media. But there are also some other applications where low latency is required. Betting application is one of them. In general, most of the requests we have today from our customer is to provide a latency which is equivalent to what they can offer with broadcast, which means 3 to 8 seconds between the encoder, the delivery encoder input to the display. Sports usually drive large audience, which means that we need to deliver this at scale, which is challenging in general, and doing that in low latency is even more challenging. Monetization is also key because these are high cost contents. So we need to have a proper support, a good description of content protection using DRM. We also need to have digital insertion capability on this type of service. And because these are very popular content, we need to address as many devices as possible. So we need to have a support of Dash and HLS. So there are several issues for interoperability. So I just mentioned 3 of them here. When we start to make some first experiment with low latency Dash using CMAF, we could see that many players had some issue with bandwidth estimates. So there are solutions that exist using new algorithms to estimate the bandwidth. It will take time to be implemented and to be deployed on all the players. And we have good hope that we won't find the same kind of issue with low latency HLS because the issue found with Dash are linked to the chunk transfer encoding that we do not have in low latency HLS. The second point is about service description, which is a nice tool provided, offered in Dash. It's well understood. Customers see the value of this kind of tools to control the experience of the user. There isn't an obvious equivalent of this service description in low latency HLS. At least this needs to be documented. Digital ad insertion is a complex workflow in general with many elements from different vendors that need to talk together. And this becomes even more challenging in a low latency environment where there is no room for any buffering anywhere on the network. So what should we do to improve this interoperability? We need to describe more the different elements of the workflow. Taking the service description in Dash, we need to define how this X server control tags in HLS can be used to achieve the same type, provide the same type of information. On the digital and insertion side, we need to describe in detail how this should work in a low latency context. And last but not least, because this was an initial promise of CMAF of having one set of media files, today we still have two sets of media files for low latency live due to the use of path files for HLS and chunk transfer encoding for Dash. To improve this situation, we should push for byte range addressing in low latency HLS that would make this compatible mode a reality and have a single set of media files.
The second scenario we'll look at today is DRM protected streaming. For this scenario, we'll be considering the distribution of high-value content. High-value content is something like a blockbuster movie, an in-season TV show, or a big league sports event. But really, it's any content where the content rights holder believes the distribution warrants higher protection. To meet this higher protection requirement, CMAF compliant encryption is utilized, which is just the common encryption standard. On-device security is going to be guaranteed by DRM vendors. And in order for this content to reach the widest audience possible, we will consider the deployment to be to a multi-device ecosystem. What this means is we really want it to hit every mobile phone, smart TV, set-top box, desktop that is possible to address with this content. Taking that all into consideration, a few issues of interoperability come forward. The first is that the DRM systems available across devices can vary. There's the three main DRM systems, Microsoft PlayReady, Google Widevine, and Apple FairPlay, but the device that they are available on varies depending on the device manufacturer's agreements with each of these individual systems. This leads to other problems like differing approaches to content security features in each of these DRM systems. A couple examples of this: how the initialization data is carried in the segment formats, how the key exchanges are securely done between the client and the license server, and even in-stream features like key rotation, whether it's doing a full acquisition of the license or just a root leaf licensing system. And finally, even in the aspects of common encryption that the systems implement together, there are actually optional and underspecified aspects of MPEG Common Encryption Specification that cause differences in implementations to occur. Things such as encryption scheme support requirements, IV handling and sizing, and then the encrypt skip patterns that are present in some of the schemes. So for us to meet our interoperability goal of a single set of CMAF segments for this scenario, we have to place constraints on the authoring of the segments. The first constraint is going to be the actual scheme used for encryption. We're going to settle the old debate, CENC versus CBCS. The answer? CBCS. CBCS is the only encryption scheme utilizable in both Dash and HLS, and has been implemented by all major DRM vendors within the last few years. Now, choosing this scheme means that we have to further clarify a couple aspects about this scheme. First is the initialization vector. Technically, the Common Encryption Standard allows both 8-byte and 16-byte IVs, but the technical details of CBCS make a 8-byte IV invalid, so a 16-byte IV should always be utilized. The next aspect that needs to be clarified is encrypt skip patterns. 19 for video and 10.0 for everything else are the encrypt skip patterns that should be utilized when no constraints are specified by a codec binding to the ISO BMFF format. This is because DRM systems have not universally been implemented to use arbitrary encrypt skipped patterns. Instead, you are constrained by the minimum implementation that has been done. Now, further codecs may provide explicit requirements for encrypt skip patterns, but to date, none have so far. Taking all of these, you should be able to produce well-formed CMAF encrypted content that is playable in both Dash and HLS across a wide variety of devices. But you may actually target devices that are older or unable to play the CBCS variant. And so in reality, there is a potential of having a duplicate CNC version out there. And when you're deploying it, you need to make the choice as to if those devices are worth that deployment. Finally, the third scenario we'll look at is dynamic ad insertion. In this scenario, we'll consider that the content being distributed has an opportunity to be monetized by the distributor. That means they can place ads in it. The advertisements that the distributor is going to place into the main content are going to be independent assets, so we want to combine them logically, not via an actual single encode. And because they are independent assets, we want to make sure it's as seamless as possible so that the experience does not seem like separate assets. Seeing something like a buffering spinner between assets is going to be a bad user experience. With dynamic ad insertion, seamless asset transitions are the biggest point of interoperability. But seamless asset transitions are the hardest thing to get right. You want frame level accuracy to ensure that you don't see the next scene prior to going into the advertisement. You need cross-rendition alignment to ensure that adaptation across asset boundaries does not result in a difference of view. And in the main content, you need to ensure that IDR frame placement is done correctly so that you can transition in and out of the advertisement asset seamlessly. Outside of the actual content conditioning, content streams may have more features than an advertisement. Things like dubbed languages or alternate views or alternate audio are all very possible in main content, but not very ubiquitous in advertisements today. And finally, we have a common need to trade off the implementation complexity with device reach. Now, you really want to target both high and low power devices to maximize your monetization ability, and those devices are going to have varying media implementations. And the higher amount of complexity you require to do proper ad insertion, the more bugs that you're going to see across the device set. So you need to find a good balance between the two. So when we consider CMAF interoperability for the dynamic ad insertion scenario, we actually have to think about restrictions at two levels of the CMAF model, the encoding object level and the logical object level. At the encoding object level, the first thing we do is consider splice conditioning requirements for the insertion points. This is to ensure that we have our segment boundaries and IDR frames to enable the splicing of different assets together. The other constraint we consider at the encoding level is the actual encoding consistency requirements across assets for video, audio, and text components. This is to ensure that device implementations do not need to adopt the complexity of transitioning encoding types across asset boundaries. While it is possible for some devices to do this, it is not possible for others to do it in a seamless manner. Finally, at the logical object level, the mismatch in features needs to be addressed by specifying a logical mapping of structures in the CMAF realm when equivalent structures do not exist on both sides of the transition. Unlike the encoding pieces, the logical matching is actually a responsibility of the manifest format and does not imply additional encoding restrictions. Hopefully it's clear that CMAF can provide its promise of interoperability with Dash and HLS in the most common of scenarios. There's just a bit more definition and constraints that need specification for it to be true. At the CTA Wave project, we want to ensure everyone does not have to derive these constraints on their own, and have started putting together the Dash HLS interoperability specification to properly capture them. This specification has two main priorities for interoperability. The first is to analyze the CMAF, Dash, and HLS specifications to identify necessary cross-constraints and restrictions that enable a single CMAF object to be used in both a Dash and HLS manifest. The second is to specify the signals and structures necessary to enable cross-conversion of Dash and HLS manifest carrying interoperable CMAF content purely at the manifest level in order to enable optimized streaming delivery. To keep this specification rooted in practicality, these interoperability details are specified through the lens of interoperability use cases. For our first publication, we are targeting 5 basic streaming scenarios: basic on-demand streaming, basic live streaming, low latency live streaming, encrypted media presentations, and presentation splicing. You may notice that you heard about a couple of those today. We feel the need for this specification in the industry is great, and we hope to have a first publication available in Q1 2021. If what you've seen today interests you and you want to get involved and help us make this specification even better, please join the CTA Wave. Email standards@cta.tech. You can also raise additional interoperability use cases through our GitHub repository, or if nothing else, you can feel free to reach out to me, zachary.cava@hulu.com, to discuss this specification further. Thank you, and have a great day.